On the third day of Christmas, my teacher gave to me. Which equation would you probably start with? Which equation would you probably start with? We have Christmas tree plus snowman plus Christmas tree is 17. Reindeer plus snowflake is 12. Reindeer equals snowflake. Reindeer minus 3 equals snowman. We're trying to figure out Christmas tree. Which equation are we probably going to look at first? Sabrina, the first one. Not the first one, nope. Not the first one. Emily? Maybe. There's something else I want to look at first. Okay. Says reindeer equals snowflake. This is important. Right here. Reindeer equals snowflake. Because that tells me that my reindeer and my snowflake are the same number. If reindeer equals snowflake, then those have to be the same number, right? It has to be 2 equals 2. 4 equals 4. It has to be the same number. Which tells me then, how when I look at the second equation, I have reindeer plus snowflake. Jackson, what does that tell me? All of these have to be the same number. Alright, keep going, keep working. You should have something written down. I don't know what I just did here. Alright, so, wow. Let's talk about reindeers and snowflakes. What number is going to work for this equation? Something plus something plus something equals 12, and it all has to be the same number. Maybe tricky? 9 plus 9 plus 9 does not equal 12. 9? 4. Very good. 4 plus 4 plus 4 equals 12. I have other reindeer. This reindeer also equals 4. That snowflake also equals 4. 4 equals 4. Does that make sense? Yes. Yes, that works. And reindeer. Reindeer is 4. What might be the next equation that makes sense that we try and solve now? Sit up, please. Bentley? 4 minus 3 equals snowman. What is snowman? What is snowman? I know, super tricky. Kaylee? 1. Snowman is 1. Not right this snowman. I also know this snowman, which is 1. Alright, I have Christmas tree plus 1 plus Christmas tree equals 17. I have 2 Christmas trees. What does that tell me? 2 Christmas trees in there. What does that tell me, Madeline? These 2 are the same number. They're the same number. Something plus the exact same something plus 1 is 17. And you'll know, plug something in. 5's so easy, right, Ada? So I might say 5 plus 5 is 10, plus 1 is 11. Oh, that's too small. I need a bigger number than 5. What if I try 10? 10 plus 10 is 20, plus 1 is 21. That's too big. So I need a number bigger than 5, but smaller than 10. Ada Washington? 8. What is 8 plus 8, Ada? 16, and 16 plus 1 is 17. Does that make this equation true? Yes. What is Christmas tree? 8. What is Jackson? What's Christmas tree? 8. On the third day of Christmas, my teacher gave to me. Alright, go ahead and erase your space, erase your board. Throw your materials back, and I need you to get out your math notebook and your counters from your math kit. So your title for today should say, how can I use an array to show multiplication. That is what your title for today is. In multiplication, we've learned how to show visual models. What two visual models have we learned? What are two? What are two? Piper, give me one.
A bar model.
We've learned a bar model. Love a good bar model. What else have we learned? Really? Circles and dots. Today we're going to learn another visual model. And we've actually already done it once. A long time ago. And it's called an array. Remember our 100 angry ants? And they arrange themselves in 2x2s and 3x3s and 4s. That is an array. You have that note in your notebook. Turn back to your glossary. It's like the very first vocabulary you got in there. No, it's not working. Oh, why are you in the back? Next, let's say
The master vocabulary in the back.
I know. No. Why are you writing on that page? Go for it. Go. Okay. What is an array? You have that definition down from way back from August and September. Naviana, what's an array?
An array is an organized big number into smaller groups, rows and columns.
So we can arrange numbers into bar models, circles, and dots, and we can arrange them into rows and columns, and we call that an array. That makes sense. If you like circles and dots, it's going to look very similar to circles and dots, but a little more organized. Sit up. Alright. We're going to make the multiplication equation 6 times 2. And we're going to do that with our counters. But first you're going to draw it in your notebook. So in your notebook, write 6 times 2. Turn back to the page that we're working on. First number in our equation is the number of rows. So in this case, we're going to have 6 rows, and it's going to be weird because we're going to stack them up vertically because rows go across. Okay? So draw in your notebook, and then we'll make encounters in a second. I'm going to make 6 going down so that I have my rows going across. Does that make sense? Okay, Sabrina,
Who wants to write it down?
you are drawing this. I would like you to draw an arrow to that first number in your notebook and put rows. Because that first number tells you how many rows. We're taking that stuff together, using the other side of the desk. But see, that's fine. The second number tells how many columns. Columns go up and down. So in 6 times 2, we have 2 columns. So I'm going to make another column of 6 counters. have 6 times 2 drawn in your notebook with arrows telling you what they represent. See how I have 6 rows going across? 1, 2, 3, 4, 5, 6, right? And then I have 2 columns. Does that make sense? What is this product of 6 times 2? You have the model right there. Count it. What is the product of 6 times 2? Elliot? 12. This should equal 12. That makes sense? Check this out. Remember when I told you what this symbol means? I know you guys think it means times, but it doesn't. It means something else. 2 words. Santiago?
Calling the groups.
Nope. Well, close. Daddy? Groups of. Remember, our multiplication symbol means groups of. So this reads 6 groups of 2. Hey, look. Doesn't that look like circles and dots again? 6 groups of 2. Yeah.
So circles and dots are really like the same thing.
Yeah.
But you just use an order.
Yeah. Are you going to tell me you don't feel good? Okay, what?
I was going to tell you that whenever if you do it this way, it'll be 2 times 6.
Okay. Are we good?
Yeah.
Alright. Let's do some practice. Get out your counters. You're going to build it on your notebook. I want you to build 4 times 3. Build 4 times 3 and then stop. So we have 4 rows and then 3 columns. Notice my rows are relatively straight. Your dots should not be all over the place. Draw 4 times 3 in your notebook with the equation. So you're drawing that array and the equation in your notebook. Four times 3 equals what? 4 groups of 3. 4 rows of 3. 4 times 3 equals what? Nabiana? 12. Great. Clear counter. 6 times 1. 6 times 1, a little bit trickier. I have 6 groups of 1. How many things do I have? I have 6 different groups of 1. How many things do I actually have? Jackson? I only have 6 things. My array should probably look like that. 6 groups of 1. Alright, what I want you to do now is you're going to build each of these equations with your counters first. Then you're going to draw a smaller version in your notebook with the answer, with the product. Does that make sense? So build these equations with your counters on your desk, and then when you finish, draw the picture and solve the equation in your notebook. Okay? Alright, get started. 1, 2, 3, eyes on me.
1, 2, eyes on you.
You learned when we did our rotations last week and your eyes are on me, you're not writing, you're not playing with counters. That multiplication has to have equal groups. You cannot have groups where somebody has 2 cookies and somebody else has 5 cookies. They have to be equal. Look at our arrays. Every single one of our groups, if I went back and circled it, you would see they all have the same number inside. They have equal groups. Does that make sense?
Yeah.
So when you're drawing your array, and you have one guy sticking out, that tells me, uh-oh, you didn't make an equal group. Do you see what I'm saying? Your array should look very rectangular or very square-like. It should not look like a flag. If yours starts to look like a flag, we've done something off. Does that make sense? Alright, keep going. You guys are doing a great job. Alright, if I'm solving 7 times 4, 7 times 2, my array should look something. 3, 4, 5, 6, 7, and then another group of 7. Doubles. My favorite. What is the product of 7 times 2? The product? Sabrina? 14. What's the product of 9 times 4? What's the 9 times 4? On the other. 6. What about 3 times 8? What was that product? Naviana?
32.
No. Ada Washington?
24.
24. What about 4 groups of 2? 4 groups of 2. Piper?
8.
8. Alright. What I would like you to do is move your counters to the side. Your notebook's not closed. Open your notebook. We're not done. We're going to solve this word problem. We will use our counters, but we don't need them quite yet because that's not until step 3. Step 1 is read the problem. Someone read this problem nice and loud. Ada Tracy, nice and loud. We don't need this part.
Miss Harvey's class had 27 students. Each time the students prepare to leave the classroom, they form 3 equal lines. How many students are in each line?
Very good. Very good. What am I counting? What am I counting? Step 1 is read the problem. Step 2, I need to know what I'm counting. Lindley, what am I counting? I'm counting more than just students. I know how many students she has. She has 27. No, I know how many lines of students she has. She has 3 lines. Let's quit playing with counters. Ada, what am I counting? Students in each line. Slightly different. A little more complicated. When we use multiplication, get your mittens off your hands. When we are doing with multiplication and eventually division, we're talking about groups. So we need to know how many students are in each group. In this case, how many are in each line. What could be my answer sentence? What could be my answer sentence? Kaylee?
Miss Harvey's class, Miss Harvey's students are in.
No, I know how many lines there are. There are 3. Where your was correct. Maddie? I love it. Go ahead and write that down on the next blank page. If you have room, you can write it at the bottom. So it's not enough to say students. It's not enough to say line. What we are actually counting are students in each line. It's really long for this one. Do I know the total or the whole? Rena? You sure? Is on what? Yeah, she has 27 students. Count out 27 counters and put them on your notebook. Those are all her little friends. So count out 27 counters and put them on your notebook. Now that you have 27 on your notebook, I want you to hold up 3. Hold up 3 counters. Pick out good ones, because those are your 3 line leaders. They're making 3 lines. So place those counters either on your desk or on the other side of your notebook. Line leader number 1, line leader number 2, line leader number 3. These are my groups. That's my line leader. Now, I need to arrange the rest of my crazies in lines. Should one line be longer than another line?
No.
Why? Why should one line not be longer than the other? Jada?
Because it won't be equal.
Yes. We're all about fairness today in math. Has to be equal groups. So we have 1, 2, 3, 4, 5, 6, 7, 8, 13. What's the math equation that goes with this array? We just made arrays based on math equations. Now we have an array. We need to come up with the math equation. What is the math equation? Mamiana?
27.
That's, okay. Do I have 27 rows or columns? Remember, I have rows and columns. Madeline? 9. 9 groups of 3. 9 groups of 3. If I wanted to make this circles and dots, because I like circles and dots, here we go. Here are 9 groups of 3. This is just another visual model.
Oh.
What is the product of 9 times 3? It should be, hopefully if we did it right, the number of kids in our class. Those are the kids we're lining up. Kaylee? 27. So wait, is my answer 27 students in each line?
No.
No. It's not 27 students in each line. How many students are in each line? Or in each column? No. I've sharpened the screen for a reason. Ada? 9. Here's one line. Here's another line. Here's another line. There are 9 students in each line. Does this make sense?
Yes.
Make sure your notebook looks like my notebook. Make sure you have an array. Make sure you have an equation. And make sure you filled out your answer sentence, please. Arrays always have to be equal groups. 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 If somebody repeats it over and over again, it's probably important. Is it probably important?
Yes.
Yeah. You should probably write down important things. Let's say I'm saying 4 times 2 equals 8. Go ahead and write this in your notebook, please. That first number in our equation is telling us how many groups. And we know that because we read this equation 4 groups of 2. So that first number column, because you're writing this down upside with counters, should say how many groups. The second number tells you how many things in each group. So if we have 4 groups of 2, I have 2 things in each group. Does that make sense? And then my last number, my product, after I figure out my total groups and things in a group, tells us how tells you how many things in all. So in this case, I have 4 groups. Inside each of those groups, I have 2 things. And then when I count up all my things, I have 8 things in all. We're going to use this and arrays a lot in the next 2 weeks. By the end of December, you will know all of your math facts, specifically your multiplication facts, starting at 0, going all the way up to 10, which will be super exciting because then over break you can practice and get better and faster at them. So every day until the 21st, let's say you're with me, we're going to be doing multiplication and specific multiplication facts. Okay? Yes.